Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Patel, and we are going to solve another example from velocity and mechanism by relative velocity method. So this is the example from your question bank. I have taken this example because there are two pistons are there, and one is a reciprocating horizontally and second is a vertically. Because the third rule, you know, the slider, the direction of slider we always draw from the origin, but in this case you have to see there's two sliders are there and one is a vertically sliding. So this will be very interesting. So let's solve this. But whenever you see this example in a book or in a question bag, there is a acceleration is also given because this example is from the acceleration. So that we will discuss later on, but right now we will just find the velocity of this mechanism. Okay. So in mechanism as shown in figure, the OA crank, which is given at a 30 degree, direction is also given which is in a anti-clockwise direction. Okay, so two sliders are there, B and D. B is a horizontally sliding and D is a vertically sliding. So length of all the links is given. So we have to find the sliding velocity of B and D and angular velocity of that CD link. Okay, so first of all we have to draw this. As you can see, this is a very large scale is given because largest dimension is a 1050, means 10105 centimeter, which is very large. So we have to descale this dimension. Descale ratio we can take 1:10, means in actual 10 mm will be 1 mm in our drawing. So 105 centimeter will be only 10 centimeter in our drawing sheet. Okay, if you have the less space in a drawing sheet, so you can take very small scale also. I have taken 1:10, you can take 1:12 or 15 also. So this dimension will be small. Okay, so we will take here 1:10. Okay, so 1 mm in our drawing, actual will be 10 mm. Okay, so as you know that you will draw this space diagram. But then, how you will start the velocity diagram? You know the rule. First of all, we need the velocity of any element. Here the RPM is given. So RPM is at 20 RPM. So RPM of this AO crank. So we will find the angular velocity. Angular velocity 2 pi n by 60. Then we will find the linear velocity. Linear velocity is nothing but angular velocity into length of that link. But remember that whenever you use this omega into length of that link, remember that we always multiply the length in a meter always, because this is we use the SI unit here. So velocity, if you find the velocity in meter per second, if you want the velocity in meter per second, you have to multiply length in a meter. And remember that length of link always given in a mm. So we have to convert that into meter, divide by 1000. Okay. So 300 mm is the length, but we have converted that into meter. So 0.3 meter we have multiplied, and we will find here velocity. You can see the velocity of this A is a very small, 0.627 meter per second. So we have to choose the scale very carefully. And how you will choose this scale? Always remember that this is the velocity and I want to draw this velocity. What will be the length? Remember that depend on that we have the space, and if I want this velocity in a 6 centimeter or 60 mm, I will choose that scale. Means 10 mm is equal to 0.1 meter per second. Okay. So 10 mm is equal to 0.1 meter per second. If you have large space, and you can take also smaller scale also, like 10 mm is equal to 0.05 meter per second, and this velocity vector in your drawing will be around 12 centimeter. Okay, so we can choose any scale, depend upon the space we have, and accuracy you can obtain in that scale. Okay, so now 0.627 into 10 divided by 0.1, and how you will find the first vector length. So this is very easy calculation. 0.1 meter per second is equal to 10 mm. So 0.627, what will be the length in a mm? You will get here 0.27 into 10 divided by this 0.1. So you can see the calculation here and you will get 62.7. Okay, very easy calculation is there. Let's start the velocity diagram. So rule number 1, all fixed point will be on a origin point. So I will take here one origin point, and which fixed point I will locate here? Only one fixed point is there, which is a O. Now with respect to O, A is rotating in this direction. You can see this in anti-clockwise direction. So we will draw this vector in this direction perpendicular to length. Okay, and length will be, you know the length, 62.7 mm in this perpendicular direction using the set square from O. Okay, velocity of A with respect to O in this direction like this. Okay, and you will get here this point which is the A, and if you know, this will be the velocity of A, and this distance is a 62.7 for drawing. Okay, so now how you will draw the other points here? With respect to A, you can't locate the C in a velocity diagram because first we need to find this B. Okay, we will find this B point in a velocity diagram. So B, you can see B is a slider which is sliding in a horizontal line. So you know that this slider is always will be in this horizontal line which is passing through the O. So this B point, this B slider will be on this point. But this B slider is also on this AB link. You can see this AB link here, and with respect to A, this B is also moving. Okay, so with respect to that A point, with respect to A, velocity of B will be perpendicular to link. So I will draw this perpendicular, okay, from this AB. I will draw here, which will be like this, and direction, as you know, that will be perpendicular to link. Intersecting point will be here, and it give me the B point. This B slider is here. Okay, I have located that. Now connect these 2 points here like this, and okay, erase the extra lines here. So now we have located this B point. Now we are going to find this C point here. C point. You can see this C point here. C point is on a AB link. AB link. AB connecting rod. You can see this C point. So C point in a velocity diagram will be here on AB, this AB vector, on AB vector. So how you will find this C point? Now we have to take here ratio, rule number 4. So AC divided by AB. So you know the distance from A to C and A to B. Okay, AC divided by AB in a space diagram is equal to, let's say, small AC divided by small AB. And this small AB you will find from this distance here from A to B. From this A to B you will find this AB distance also here. So 3 data is here, and we will find this small AC, and we will locate the C point in this diagram here. Something C point you will find here. When you have this C point, how you will find this D point? So as you know that with respect to C, this D is on a CD link. So with respect to C, motion of this D point will be perpendicular to this link. So I will draw this perpendicular which is passing from this C point here. C point is here. But D is a slider which is sliding. Remember that this is the only one slider in our all the question which is sliding vertically. So rule number 3, direction of slider in this case is a vertical. So I have to draw vertical line which is passing through the O point like this. Okay, so whenever the slider is sliding horizontally, I will draw the horizontal line from the origin point. Same as right now slider is sliding in a vertical direction, so I will draw this vertical line and intersecting point. This intersecting point give me this D point. Okay, this point is here, nothing but D point, and you will erase the extra data and you will get this velocity diagram. Okay, in velocity diagram, line can intersect each other because 2 points can be possible same velocity. Okay. So this is the velocity diagram. You need the velocity of B and D. So velocity of B means this point, measure this distance from O to B, you will find the velocity of B. And if you measure this distance O to D, you will find the velocity of D here and here velocity of B. Okay. Thank you.